Hey everyone, in today's video, we're going to see about Softmax and why we need Softmax instead of other activation function. So Softmax is nothing but it gives a probability of possible outcomes, and mostly it is seen in sequence modeling. We'll see how this probability going to help to predict a possible outcome. So first, let me take a sentence, for example, I love. So the suffix may be anything. So the probability which obtained was cat, dog, bird, and fish. So these were the possible outcomes for the sentence I love dash. So this probability just obtained from the predicted values. So any algorithm that we use, it just gave like these many probabilities. Now we need to choose which would be the a perfect match for the sentence. So mostly cat have been obtained, and dog, which will be second, and third is bird, and last fish. So none of them going to say I love fish, right? So this probability have been calculated not by Softmax, but from the any neural network or any modeling algorithms like machine learning or deep learning models that we use. So the outcome would be like 2.0, 1.0, 0.5 or minus 1.0 for fish. Now, Softmax, if we use on top of 2.0, it gives 60%. So this is a formula for Softmax where output of Softmax is equal to e power output with the list of elements, possible outcomes. I is possible outcomes and Z is your each outcome like cat, dog, bird, fish, and divided by summation of all together, like every possible. So this is how we calculate the percentage, right? So same thing, we just calculate the probability with the score. So for 2.0, we have list of which is 1. So 2.0 divided by 1, which will give the 60%. Now, what is the advantage of Softmax is when we sum of all these possible outcomes, the summation is supposed to happen 1. So that is the advantage of having Softmax. But how it is an advantage compared to other activation function is, so when we say if I'm like randomizing it or choosing anything with a probability, so here I just have like 93% of fish. If I include any class, again I'm randomizing it. So any randomization that I do, the summation is 1. It's supposed to happen 1 as a summation. So any number I take, any probability that it predicts, and Softmax does is one thing, which is summation to exactly 1.0. So how many number of times that I do, it is that. Or even adding a class, it gives me that. So any probability prediction can happen. It may be fish sometime, it may be dog sometime, but summation always is 1. Now we'll see like step by step how. So the raw output that we are calculating for possible outcomes is dog, cat, and bird. So as we saw, 2.0 and 1.0 and 0.5 were the identified possibility based on the training. So after training, we just got this. So at final layer, we apply Softmax, and I'll tell you like why in the final layer we put Softmax. So the next step is exponential we take. After taking exponential for 2.0, we get 1.0. So still it is not in percentage and it is still in the value. Now next is summation we do, and we get like 1.59. So after the summation of all together. Next, when we do the normalization, we get divided by summation. So summation is nothing but the formula we saw on previous step. So for this, we took the summation. So At last, we got the percentage. Summing it up, we get 100% of it. Next, if we add temperature in Softmax, it sharpens, it even more specifically gives the most probable solution. For example, if I give, so now in temperature 1, we have like cat, the obvious one. If I go like 5, it is like very close towards each other, but still cat is the highest probability. But when you look at it, it is not the obvious one. It looks like this is like really close. So when we use temperature, it scales the output, and if we reduce the temperature even more, it gives the exact obvious one. So that is how the temperature scaling works for Softmax, and it is good to have. So you can have the entropy also uh, in order to show which is the best prediction. Then comparison. Now I'll tell you like why we need Softmax comparatively with the other activation function. So when you use Sigmoid, it tunes the output between 0 to 1. When you go with Tanh, it is minus 1 to 1, and ReLU is 0 to infinite. So when we handle inputs, it will eliminate the negative value when it comes to ReLU. But you cannot just have a percentage, probability percentage for it. Same goes with Tanh. But when you go with Sigmoid, it will give you from 0 to 1 the probability, but it acts only for one input. When it comes to Softmax, it handles for all the input that we give. It can handle multiple inputs. That is why we go with Softmax. And we also prefer Softmax for any sequential model that we use, like text to speech, audio to speech conversion. So any sequence that you have, you will have, you can go with the Softmax activation function at the final layer. So in between, you can have Sigmoid, Tanh, ReLU and all. But when it is in the final layer, you can have Softmax when it comes to sequential model. And when not to use Softmax is, don't use it for multi-level classification because it gives the possible percentage, probability percentage. It cannot just go with multi-level classification. And regression task, we cannot go with Softmax because regression is supposed to have like multiple numbers in the sense like all positive numbers, sometimes negatives also. But it is not going to have the probability for each score. It varies in points or in a numerical way, like 0.75, 0.73, like that, close towards the actual. Next, hidden layers we should not use. As I said, we can go with ReLU, Sigmoid, Tanh also, but Softmax we should not use in hidden layers. So yeah, and it is also easy to have cross-entropy. Cross-entropy is nothing but it gives the probability of the model, how much it is correct. So it gives you cat means how much the cat predicted is correct. So that is what cross-entropy do, and it easily goes with Softmax. So yeah, I hope you found this video helpful, and that's all I have for today. See you all next video. Thanks. Bye.